Here's an overview of the Peace-Drone XR for extended range on the date of its maiden flight. I built this one very similarly to the previous Peace-Drone, although this one is meant for extended flights for hopefully 30 minutes or longer. It has a Dragon Link control. I'm using a GoPro for FPV and onboard recording, mounted in the nose. I omitted the nose pod concept because this is going to be a dedicated platform for this camera, so I just mounted it in there removably, but more or less the only camera that's ever going to go in this plane. We have the same 30-inch fixed canard with a 6-inch cord. It has no control surfaces. It is mounted to the fuselage at the very front with rubber bands, which are wrapped over carbon arrow shafts, which extend from the nose to the rear of the plane, and are engaged the rubber bands here and then here for breakdown. The main wing is 60 inches long, 2 sections of arm and wing, 5-inch cord, 1.5-inch control surface, configured as elevons, almost full span, minus a center section to provide slightly cleaner air to the prop. Both the canard and the main wing are held on by these rubber bands that protrude from the fuselage and are wrapped around a carbon arrow shaft, one on the right and one on the left, that extend the full length of the fuselage all the way to the front here. And so for the canard mounting, these rubber bands are wrapped over the canard and onto this carbon arrow shaft on both sides. And then for the main wing, these rubber bands are wrapped over and over the carbon arrow shaft here. I've left one against the fuselage here on both sides to provide that grippiness for the wing when it's mounted, as well as just a spare rubber band if one of these should break. I can always pull that one up to take its place. This is the infrared sensor for the stabilization feature of the Cyclops OSD with return to home. This flips down inside the fuselage for transport. Here's a Lawmate 500 milliwatt video transmitter, 2.4 gigahertz, with a cloverleaf antenna. This has a heat sink modification. It's more or less flush with the side of the fuselage, but with the heat sink externalized for better airflow there. The Dragon Link control antenna extends from the receiver, which is mounted just inside the hatch, and this is removable. The vertical stabilizers are the only component that are Depron and not foam board. This is a 6-inch cord, 8-inch height. I finished the edges with white packing tape for improved durability, and they have the same magnetic latching system, which is pretty secure, but I'm still using a little safety tape just for first few flights. Motor is an RC timer, 3536, 1000 kV motor. This generates 1,600 grams of thrust with this 10x7 3-bladed master air screw prop. So about 1,600 grams of thrust, and that is using one 2200 milliamp hour Turnigy Nanotech with a capability of hooking up 4 of those in parallel. So I would consider that my minimum new battery thrust for the long-range Peace-Drone. I've mounted this higher above the fuselage, even though it's detrimental for aerodynamics and transport, but to give the best possible prop clearance. This propeller was really awesome, the Master Air Screw 10x7 3-blade. It was a little more expensive, of course, but still well under $10, and it was perfectly balanced right out of the package. It generates an amazing amount of thrust, and with this 1000 kV motor, I'm getting over 4 grams per watt of thrust, which is quite efficient. There's a little bit of a conundrum with the pusher prop issue, the prop clearance, the landing gear height and location. Of course, this plane is going to need to rotate just a little bit in order to take off, depending on the canard angle of incidence. But in any case, this is about a 2-inch clearance at rest, and I would never feel comfortable with that being less than about 1 inch. So I've kept the prop a bit small, mounted the motor a little high. The landing gear is a bit tall and it's placed far rearward as I could tolerate, so that any angle of rotation here translates to a minimal amount of loss of clearance. The further these gear were placed forward, any angle of rotation upon takeoff would place the prop much closer to the ground, which is a bad thing. The GPS receiver for the OSD is under a piece of tape right here. It's more or less flush with the top of the hatch, but it's just under a piece of duct tape. And the provisional CG at 15 inches, which is dead center between the very nose and the very tail, I've marked here. I'm going to aim for a CG 2 inches ahead of that to start, and then work back to this point as long as it handles well. I've used a Turnigy Trust 55 amp speed controller, which has these really nice heatsink fins, as long as you cut away the heat shrink, and it's supposedly a very reliable speed controller. I've disabled the BEC partly for reliability and partly to avoid a ground loops electric situation with the OSD. It's a little more complicated than I can go into here, but let's just say that the power system for your power plant needs to be segregated as much as possible from the rest of the electronics, as they connect through the OSD and can cause problems. Instead, I've used a BEC inside the plane. Here it is in its broken down state, which is 32 inches long and approximately 10 inches tall and 8 inches wide. The canard is here, and the collapsed main wing is here, and there's the fuselage and electronics. The Cyclops OSD with return to home has an IR sensor, which I have installed on this gift card, that flips down inside for transport and then flips out and is held down to the fuselage by a magnet there. And these IR sensors point to the left and right of the fuselage to provide some auto leveling function. Coincidentally, there ends up being a little bit of a storage space in here. I haven't really allocated that yet. The wires are pretty messy at this time. I haven't stowed them because I'm still dialing in the CG and the battery location. But make no mistake, there are a lot of wires with this OSD. There's the reset button for the OSD. The Dragon Link antenna goes through this hole here and screws onto the Dragon Link receiver, which is installed on the underside of the hatch right here. There is the Cyclops OSD. It's wrapped in a gift card. The Peacetrone XR does have landing gear, which detracts from the portability a little bit, but for the weight of the plane and the type of operation I'm going to be doing, I think these are going to be helpful. These are quite light, but they turned out to be a tiny bit flimsier than I desired. Therefore, I installed a cross brace here just to provide a little tension between the two legs, and that keeps the fuselage well off the deck, even with forces applied on both the front and rear landing gear. For control, I'm using my trusty DX7 here with a Dragon Link module, transmitter and receiver, of course, in the plane. This is a super nice unit. So far, so good. Dragon Link consists of this transmitter module, an antenna, right angle adapter, which I've actually added. And most guys mount these on the rear of their radio, but I've chosen to mount it in the front as it's integral with my my lanyard hang point right here. And then I can just take this keychain off right here and just dismount the whole thing. It interfaces with the transmitter itself. Since the Spectrum doesn't have a removable radio module, I had to add this switched 3.5 millimeter plug adapter, which what it does is bypasses the 2.4 gigahertz internal radio transmitter module and carries the signal as well as power and ground, of course, right to the Dragon Link right here. And so it powers down the 2.4 gigahertz and powers up the 433 megahertz. And so I can easily switch back to the 2.4 gigahertz by just unplugging the Dragon Link, removing this, and then reverting to the normal antenna and transmitter. Dragon Link has a little button right here, which is the bind button, as well as how you set the fail-safe. It's really remarkably easy to use and set up so far. And as long as the Dragon Link is plugged in, all the other functions of the Spectrum radio perform exactly the same. In fact, I could take this off, put an ordinary spectrum receiver in the airplane, unplug this, and all the same settings would apply for the same model. Range testing the Dragon Link is accomplished by putting on this dummy test load that they provide when you buy it, and then walk the usual 30 paces away and articulate the controls, and if they move, you're good. I got to 40 paces and was getting 100% response, and at about 60 paces I was getting about 75% response, so I would call that a passed range check. My ground station is a Lawmate 2.4 gigahertz receiver with this Q-planar antenna mounted on a tent pole, which was about $15 from eBay, and that tent pole is plugged into a socket in the corner of this case, just with some zip ties. This case is from Harbor Freight, which is $26, and that allows me to keep my antennas. These are some 5.8 gigahertz there, and spaces for the 2.4. I've got Fat Shark goggles, which I'll put on in a moment. I'm going to first be recording my flights with this Sony Handycam, which has a analog in and some spare space for other stuff. So I hope this goes well. I'm going to fly some line of sight, and if all goes well, I'll do a little FPV